All right, so the next type of proof we're going to look at is proving a shape is a parallelogram. So you can see right here, there is the difference. We don't know this ABJK shape is a parallelogram yet, so we can't use the rules. But our job is to find rules or look for clues that make it a parallelogram. All right, again, we don't know it's a parallelogram yet, but we want to find those same rules, same ones we've been doing. Two pairs of opposite sides parallel, two pairs of opposite sides congruent, two pairs of opposite angles congruent. Or there's that bonus rule. That's always a good one to look for. The bonus rule where one pair of opposite sides are congruent and parallel. That's always a good one to look for. All right, so we're still looking for parallelogram rules. We just need to find them instead of the fact that we know it's a parallelogram already. All right, so we'll get the given in. There's a few this time. There's the bell. We have angle 1 congruent to angle 2. We have angle 2 congruent to angle 3. And we have segments AK congruent to segment BL. Alright, marking in 1 congruent to 2. 2 is congruent to 3, so those are only going to get one arc each, you can see. And AK right here is congruent to BL right there. Alright, so we know a lot of stuff here. And I'll tell you what I see first. I know 1 is congruent to 2, 2 is congruent to 3, and that would make 1 congruent to 3. What I see there, that kind of looks like an isosceles trapezoid, which is not what we're trying to prove. So I'm going to kind of avoid that for now. But here's what I see right off the bat. I see angle 1 congruent to angle 2. Now if you turn your paper sideways, and I'm going to do this with my highlighter, right there, and if I go like this, and you turn your paper sideways, like I said, angle 1 and angle 2, if you look real closely, those are corresponding angles. So right off the bat, I noticed that those corresponding angles are congruent, which means line AK right here must be parallel to line BJ, because lines are parallel if and only if corresponding angles are congruent. Alright, so we got a piece done already. That was one of our very important parallelogram rules. We have a pair of parallel sides already. So now what we can do, let me mark that in actually. Let me get, how about red? We'll mark these in as parallel. That's one of our two pieces. We either need to prove that these two sides are parallel, or we can try to get our bonus rule in play. We can prove that AK and BJ are also congruent. That will let us use our bonus rule where that one pair of opposite sides are congruent and parallel. Now what I see already, we already know something about AK. We have a piece of information about AK. So if we can somehow, some way, tie in this segment over here that we know is parallel, right here, segment BJ, if we can tie that segment in, somehow connect it to AK, we'll be done. So there's a reason, like I always tell you, there's a reason that they give you this information. They told you angle 2 is congruent to angle 3. We haven't used angle 3 yet, but if you look over here, that's just an isosceles triangle. So we can say for sure, we'll do that in green, we can say for sure that BJ and BL are congruent. And again, I only give it one mark because this already has one mark. We're not going to change the different marking lengths there. So I know, let me scroll down a little bit, I know for a fact, because those two angles are congruent, that the segments across from them are congruent. So I think one of the ways we said that was in a triangle, sides are congruent if and only if angles opposite that are congruent. All right, now I know it seems like I'm just kind of coming up with this stuff real easily, but remember, it's kind of a process of elimination, right? We only had a few options. We figured out those lines were parallel. So the only other option to make this a parallelogram was to prove that, like I said, these two sides were parallel, or to prove that these two sides were congruent. That's all we had left as our options. So that's what you should be looking for. So now, what do I see? I see 3 different segments, all with that one single green slash on it. So if you look at our proof, there's a segment BL. There's a segment BL. So we can kind of connect those two, cut out the middleman, and that's what we say is our substitution step. So AK right here, congruent to BJ right there, and that's the two that we were going for this whole time. AK, not parallel, sorry about that, congruent. That bell threw me off. AK is congruent to segment BJ, and that's just substitution, right? We had 2 different things. Substitution. We had 2 different things congruent to the same piece. They were both congruent to BL, which means those 2 things must be congruent to each other. So if you look at your picture, once again, always mark it in. AK, BJ, parallel, because the corresponding angles, and I meant to write this here, this is always a good idea, just so you remember, angle 1 and angle 2 were your corresponding angles, which makes the lines parallel. And then we use substitution to prove they're congruent. So we're done, actually. That's all you need. Remember, for a parallelogram, you only really need 2 pieces of information. And we have it. We have that those sides are parallel. We have that those same sides are congruent. So we can say A, B, J, K is a parallelogram because, this is the long wording again, a quadrilateral is a parallelogram if and only if, and here's the bonus rule, one pair of opposite sides is congruent and parallel. So those are a little more difficult, but we're just working backwards. Remember, you can't use the parallelogram rules. We're looking for things that make it a parallelogram. All right, so there's that. You can try number 8. It's a lot like it if you want to try that one out. If not, I'm going to jump down to number 9 in just a second on the next video. So see how you do. Goodbye.